Another awesome area and circumference problem coming your way here. All right, we got to find the area and circumference. Woo! The twofer of the circle that is inscribed in a square with diagonal length 16. You may know what inscribed means. You might not know that term yet, but hey, I'm going to draw it up for you, okay? So if I had myself a lovely square, that worked out wonderfully, and then I had a circle that was inscribed in it. So let me try and get a circle. I'm going to have to adjust this, I think. Boom, there we go. Inscribed just means that it is touching on all sides there of the square. So that circle has been inscribed in the square. Okay. Now it says the diagonal of the square is 16. So that's going to be 16. Okay. I want to find the area and the circumference. If I want to find the area and circumference, I need my radius. What is my radius going to be? That's my goal here. Okay. Now you might be like, well, what about half of 16? Well, half of 16 is 8, but that would be this whole stretch right here. That goes outside the circle. So it's not that. Could I find my diameter of the circle? Now take a look here. If I found this length right here, okay, or perhaps this length right here, that would be the same as going all the way across the circle, right? If I'm going across the square, whether it's on the side or somewhere in the middle of the square, if I'm going horizontally across, it's going to be the same length. Okay. Well, what did I just create here? I think I just created, hold up, right angle, right? And I have the diagonal of a square that bisects the angle. So this is going to be 45 down here and 45 right here. I have a 45, 45, 90 triangle. I have my hypotenuse. What do I do to get my leg? I'm going to take 16 divided by root 2, and I'm going to rationalize that. The special right triangles, they never go away because they're so special, right? So that's going to be 16 root 2 over 2, which is going to be 8 root 2. That is this whole length right here, which is halfway across the circle. So my radius is 4 root 2. Okay. So my diameter is actually 8 root 2, which is still a useful number here, right? Diameter is 8 root 2. Radius is 4 root 2. So circumference, if I do that one first, I feel like that one's a little bit easier. Circumference is 2. Maybe I should turn off my ink to shape. Here we go. 2. How about this? Pi times diameter. What am I thinking there? We got my diameter, right? No need to do more work. So I'm going to have 8 root 2 pi. Oh, that's terrible looking. That's my circumference. Cool. So pi times diameter or 2 pi r would still get me there, right? Because 2 times 4 is going to give me 8. But that would just be the easier version of it to use. Now, as for my area, which is pi times my radius squared, my radius is 4 root 2. So when I plug that in, 4 root 2 squared. Now, to square 4 root 2, if you remember from radicals, I got to square both parts here. So I'm going to have pi times 4 squared is 16. Root 2 squared is 2. So my final answer here for the area is going to be 32 pi. That one turns out a little bit nicer, right, than the circumference. But there you go. Definitely a challenging problem. We'd probably give you a diagram on something like that, especially if you don't know the word inscribed yet. That comes in future lessons. But given that diagram, that's a doable problem right there. And that's a fun problem. That's an awesome problem. You guys are awesome. See ya.